Right beneath your feet, at this very moment, there's an invisible world humming with activity. Messages are racing through darkness at nearly the speed of light, conversations are happening in complete silence, and an entire civilization of communication exists in a realm most of us will never see. We're talking about the vast networks of underground cables, tunnels, and infrastructure that carry almost every piece of digital information you've ever sent or received. Picture this. You send a text message to someone across town. You might imagine it floating through the air, bouncing off cell towers, arriving at its destination in seconds. And while that's partially true, what most people don't realize is that even that wireless signal depends entirely on a massive hidden network buried deep underground. That cell tower your phone connected to? It's hardwired into a sprawling web of fiber optic cables, many of them running through tunnels that were dug more than a century ago. Here's something that'll blow your mind. Underneath major cities like New York, London, and Tokyo, there are tunnel systems so extensive that some engineers call them underground cities. These aren't just simple conduits for cables. We're talking about climate-controlled environments, maintenance corridors wide enough to drive vehicles through, and junction points where millions of conversations, video calls, and data transfers intersect every single second. The story of how we got here is absolutely fascinating. Back in the 1870s, when telephone technology was just emerging, nobody really thought about where all these wires would go. Early telephone companies just strung cables overhead, creating these absolutely chaotic webs of wire that darkened entire city streets. In some places, there were so many overhead wires that sunlight could barely reach the ground. Then came the Great Blizzard of 1888. New York City got absolutely hammered with snow, and the weight of ice on all those overhead wires brought the entire system crashing down. Literally, telephone poles snapped, wires fell into the streets, and the city's communication network was completely paralyzed. That disaster changed everything. City officials and telephone companies realized they had to move these networks underground. But here's where it gets interesting. They didn't just dig new tunnels. They started using existing infrastructure, old steam pipe tunnels, abandoned subway passages, even sewer systems. Over time, this created this incredibly complex maze of pathways that nobody fully understood. There are stories of maintenance workers in the 1960s discovering tunnels that weren't on any official maps, some of them dating back to the Civil War era. Fast forward to today, and the scale of these underground networks is mind-boggling. There are an estimated 350 million miles of fiber optic cable buried underground worldwide. If you laid all of that end to end, you could wrap it around the Earth 14,000 times. And that's just fiber optics. That doesn't include copper telephone lines, power cables, or the countless other systems sharing the same underground real estate. But here's what really makes this fascinating. These aren't just passive tubes carrying information. Modern underground communication networks are incredibly sophisticated ecosystems. Take a closer look at a major fiber optic trunk line running under a city. Inside a single cable, which might only be a few inches in diameter, there could be hundreds or even thousands of individual glass fibers. Each one of those fibers can carry 40 terabits of data per second. To put that in perspective, that's enough bandwidth to transmit the entire contents of the Library of Congress in less than a second. The technology that makes this possible is genuinely beautiful. Each fiber optic strand is thinner than a human hair, and it works by bouncing pulses of light off the inside surface of ultra-pure glass. The glass is so pure that if you made a window out of it several miles thick, you could still see through it clearly. Light travels through these fibers by constantly reflecting, zigzagging its way forward at about 2/3 the speed of light in a vacuum. The information isn't just traveling fast. It's traveling in complete isolation from the outside world, immune to electromagnetic interference, weather, and most forms of eavesdropping. What many people don't know is that these underground networks have their own geography, their own bottlenecks and highways. There are certain junction points, particularly in major cities, where an absolutely staggering amount of global internet traffic flows through a single building. In Lower Manhattan, there's an Art Deco building that looks completely unremarkable from the outside, but inside, it's one of the most important telecommunications hubs on the planet. If you could somehow see the data flowing through that one structure, you'd be watching a significant percentage of all financial transactions, emails, and video streams happening in the Western Hemisphere at any given moment. The security around these facilities is intense, and for good reason. These aren't just important for business and personal communication. They're critical infrastructure. Military communications, emergency services, power grid management, everything depends on these underground networks continuing to function. During the September 11th attacks, when the World Trade Center collapsed, it severed multiple major fiber optic cables running through Lower Manhattan. The redundancy built into the network meant that most traffic was automatically rerouted, but it took months to fully repair the damage. The people who maintain these systems operate in a world most of us never think about. There are engineers who spend their entire careers working in underground tunnels, navigating by maps that show layers of infrastructure stacked on top of each other like a three-dimensional puzzle. In some major cities, the tunnel systems are so complex that new workers need months of training just to learn how to navigate them safely. There are stories of maintenance crews discovering cables that have been in continuous operation for 60 or 70 years, still carrying traffic, with nobody quite sure who originally installed them. Here's where things get even more interesting. These underground networks aren't static. They're constantly evolving, constantly being upgraded and expanded. Right now, in cities around the world, crews are drilling new tunnels using techniques that would have seemed like science fiction just 20 years ago. Horizontal directional drilling allows workers to create underground pathways without digging up entire streets. They can drill tunnels hundreds of feet long with incredible precision, threading new cables through urban environments with minimal disruption to the surface. But there's a problem that's getting worse every year. These underground spaces are getting crowded. In many major cities, there's literally no more room for additional infrastructure. The tunnels are packed with fiber optic cables, power lines, water pipes, gas mains, and countless other systems. When a new cable needs to be installed, engineers sometimes have to get creative, running cables through spaces that weren't designed for them, or even removing old, abandoned infrastructure to make room. The abandoned infrastructure is its own fascinating story. Underneath many cities, there are miles and miles of old cables that are no longer in use but never got removed. The telecommunications industry even has a term for this stuff: dark fiber. These are cables that were installed but never activated, or were used for a while and then abandoned when technology moved on. Some of these dark fiber networks are still in perfect condition. Companies sometimes buy old dark fiber networks and light them up again, bringing decades-old infrastructure back to life to handle modern internet traffic. Then there are the submarine cables, which are really just underground networks that happen to run along the ocean floor. There are about 400 major submarine cables circling the globe, carrying 99% of all intercontinental internet traffic. Yes, 99%. Despite all the satellites and wireless technology we have, almost everything that crosses an ocean travels through cables lying on the seafloor. These cables are engineering marvels. They have to withstand enormous pressure, resist corrosion from salt water, avoid damage from ship anchors and fishing nets, and continue operating flawlessly for 25 years or more. The landing points where these submarine cables come ashore and connect to terrestrial networks are some of the most strategically important locations on Earth. There's a beach in Cornwall, England, where more than a dozen major submarine cables make landfall. From that one stretch of coastline, cables branch out across Europe and connect to the broader global network. The security around these sites is deliberately low-key. You might walk right past one and never know it was there. What's really mind-blowing is how vulnerable these networks are despite all the redundancy and security measures. In 2008, a ship's anchor accidentally severed two submarine cables in the Mediterranean, and internet connectivity dropped by 70% in Egypt and 60% in India. Just two cables. There have been cases of fiber optic cables being cut by construction workers who didn't know they were there, by earthquakes, even by sharks apparently attracted to the electromagnetic fields around the cables. This vulnerability has national security implications that governments are just beginning to fully appreciate. There are documented cases of foreign submarines mapping the routes of undersea cables, presumably identifying points where they could be tapped or cut during a conflict. The United States and other countries have invested heavily in systems to protect critical cable routes, but the sheer scale of these networks makes comprehensive protection almost impossible. Now, let's talk about something that sounds like pure science fiction but is absolutely real. There are systems that can detect a problem in a fiber optic cable thousands of miles long and pinpoint the exact location of the fault to within a few feet. The technology is called optical time domain reflectometry, and it works by sending pulses of light through the fiber and analyzing the reflections that bounce back. Different types of problems create different reflection patterns, so technicians can not only find the fault but often diagnose what's wrong before they even get there. The future of these underground networks is heading in some unexpected directions. As cities get smarter and more connected, the underground infrastructure is becoming a two-way system. Sensors embedded throughout tunnel networks now monitor everything from temperature and humidity to structural integrity and the presence of unauthorized personnel. This data flows back to central control centers where artificial intelligence systems can predict failures before they happen and automatically reroute traffic around problem areas. Some cities are taking this even further. Singapore has created a comprehensive three-dimensional map of everything underground, updated in real time, showing not just where infrastructure is but its condition, capacity, and projected lifespan. When a construction company wants to dig anywhere in the city, they can access this map and know exactly what they'll encounter. It sounds simple, but most cities have nothing like this. In many places, maps of underground infrastructure are incomplete, outdated, or deliberately vague for security reasons. There's also a growing movement to reclaim underground space for new purposes. In London, engineers are converting old telecommunications tunnels into routes for autonomous delivery vehicles. These small electric robots will travel through the same tunnels that currently carry fiber optic cables, delivering packages without adding to surface traffic congestion. It's a perfect example of how the underground networks we built for one purpose can be adapted for entirely different uses. Perhaps the most interesting development is how our relationship with these networks is changing. For decades, underground infrastructure was something that just worked invisibly in the background. Nobody thought about it unless something broke. Now, as we become more dependent on constant connectivity, people are starting to understand just how critical these hidden systems are. During major outages, whether from natural disasters or accidents, the conversation immediately turns to the physical infrastructure, the cables and tunnels and junction points that make our digital lives possible. What strikes me most about these underground networks is how they represent this unique intersection of the ancient and the cutting edge. You've got hundred-year-old tunnels carrying light pulses that enable technologies that didn't exist 5 years ago. You've got maintenance workers using the same basic techniques of cable pulling and splicing that their predecessors used in the 1920s, but they're working with materials and technologies that would seem like magic to those earlier generations. Standing on a busy city street, watching people absorbed in their phones, streaming videos, making video calls, completely immersed in the digital world. It's easy to forget that all of it depends on this vast physical infrastructure hidden just below the surface. Every message, every video, every piece of data is ultimately traveling through real physical cables, maintained by real people, running through real tunnels that had to be dug through real earth and rock. The hidden architecture of underground communication networks isn't just about technology. It's about human ambition and ingenuity, about our drive to connect with each other across any distance, to share information instantaneously, to build systems so reliable that we can take them completely for granted. These networks are monuments to human achievement, just as impressive as any skyscraper or bridge, but invisible, unnoticed, and absolutely essential. Next time you send a message or stream a video, take a second to think about the journey that data is taking. It's racing through darkness at incredible speed, bouncing through glass fibers thinner than hair, navigating a labyrinth of tunnels that span continents and cross oceans, all to deliver your cat video or your text message or your video call to exactly where it needs to go. That invisible infrastructure, that hidden architecture, is one of the most remarkable things humans have ever built. And most of us will go our entire lives without ever seeing it.